Hello everyone. Today I will show you how to create a drawing from a template on Fusion 360. So you can see here we already have our part all set up, ready to go. And before we create the drawing, we know we want to have a north and south isometric view. So right now in our named views we have our top, front, right, and our home view, which actually is a north end isometric view. However, we want to create a south end view, and we might want to use a slightly different isometric view as well. So in this case, I'm going to use roughly this isometric view. And to save this as a named view, we can go up here in the top right and click just this little blue corner, and that'll set us in a true isometric perspective. Now under named views, we can right click, click new named view, and now we have this named view here. If we double click it, we can rename it to whatever we want. In this case, North ISO for the North Isometric view. You can also drag down and now click the blue triangle down here to get us into our isometric perspective again. Right click, new named view, double click, South ISO. Now we have our views set up. It's time to import our template. So we can open up the template that we will have downloaded, upload it. This uploads it to our project folder, so we can use it for anything in this project folder. Now you can see it here, that F2T file. Now if we go File, New Drawing from Design, under Template we want to select Title Block Fusion 360, hit Select, and you can see the standard units and sheet sizes taken care of for us. Hit OK, and we end up here in our drawing. First thing we want to do is make sure we're on front, make sure we have visible and hidden edges selected, and we want to change our scale to 1:1. Now we can plop down our view. You can see it looks good. Now we can go up here to projected view, or hit the letter P on the keyboard to get projected views. Click that view, and then just move your mouse up to get a north view, a south view, and then a side view. You can hit escape. Now we want to add in our isometric views, so we can go back up, and from our model we can hit our north or south isometric view. Now you could have also just selected a southwest, southeast, northeast, northwest isometric views as well. However, I like having the named views as it just makes everything a little more clear. So I'll take my south isometric view, and in this case for the isometric views we don't want to see any hidden lines, just to get an idea of what the overall part shape will look like. So we'll hit just visible edges, scale also 1:1. We'll put our south view up in the top right corner, and hit OK, and we'll do the exact same thing for the north view. We'll just line it up so that it's pretty closely lined up and hit OK. And now those are set. Now we also see we have some hidden lines for features from the south end showing up on our top side, and likewise features from the north end showing up on the south end. And that just clutters things up a bit. So what we can do is right click this, hit Edit View, and from here, instead of having style from parent, we'll just click Visible Edges. And we can close that and do the same for over here, Edit View, Visible Edges. That cleans things up a bit, so now we can go ahead and start to fill out the dimensions and fill out our title block. To fill out the title block, it's pretty easy in Fusion 360. We can just double click it, and you can see there's already some placeholders for everything. So the material type, we'll double click and say 6061 T6 aluminum. Finish type, we'll just say none. CAD TA name, you will enter whoever your CAD TA is. North and south mate, you'll enter whoever that is if you know it yet. Same with south mate. And your drawing number. And the revision that you're on. Finally, if you want your name to not have any underscores in it, you can go in and edit your totem name here. Right now with the template, the way it's set up is it just defaults to the name of your project, but you can change it to whatever you want. So once the title block's all filled out, you can select OK, and everything's good to go from there. Now it's time to add some center marks and center lines. So if we go up to center mark and hit center mark and click one of our circles, here we can see that it actually doesn't have center marks extended all the way through the part, which is what we want in this case. So if that happens with Fusion 360, the easiest way to get around that is actually to use center mark pattern. Then when you select this, you can create a center mark, and I just move my mouse so it's up on top, so it's vertical. Hit enter, and there we have it. Easy as that. Do the same thing down here. And now we have the center marks set. For the center lines, we just want to click the outer sides of the cylinders, and you can see that the center lines actually don't extend all the way through the part. And we want them to, so we'll just click the center line and drag the arrow on the end so that the center line comes through the part for both the top and the bottom. And we want to make sure that they're roughly equal. So now those are set. Now we can start dimensioning our part. A helpful shortcut for this is the letter D on the keyboard. So we can hit D, and then we have our dimensions selected. When we come to dimension the outer edge of this totem piece, you can see that when we click it, we end up with this radius. Now, radius isn't really great for the outside diameter of the entire totem, and typically we only want to do that if we have less than about half a circle. So instead of that dimension, what we can do is come up here and hit diameter dimension. And regular dimension will just do what it thinks is best, but we can override that to a diameter dimension. And we can click that and place that down. Same with this one. Now you can see that it's dropping the trailing zeros, so that's an easy enough problem to fix. Down here at the bottom we have annotation settings, and we can do display leading zeros and we can display trailing zeros. So I'll just select display trailing zeros for this. If you find that it's now showing too many decimal places, we can go up here to linear dimension precision and select whatever we want. If we want it 3 decimal places, 2 decimal places, 1 decimal place, whatever we need it to do. So that's how we can set that. Now we just have to dimension the rest of our part. Start off with some easy ones here. So when you're dimensioning the part, what we want you to do for these assignments is to dimension all features on the north end referenced off of the top surface of the totem, and all features on the south end referenced from the bottom. So you can see that's what I've done here. Now we can keep on dimensioning everything. Now it just looks like we're missing one dimension here, which is from there to there. And one thing to keep in mind is we never want dimensions to go out, extend out past this. So you can click that dimension and drag it down to be within the box of the drawing. So we're going to have this 0.30 dimension be our precision fit. So to do so, have it be a 3 decimal place precision fit. We can click it and actually double click it, and now you can see we have this selected. And over here on the right, we want to change primary precision to 3 decimal places. Under the tolerance tab, we want type to be deviation. And now our upper tolerance, since this is a gap, we want it to be no smaller than this. So the tolerance should be plus 5 thousandths minus 0. We can close that, and now we can see that the precision fit has been applied correctly. Before we get too much further, it's always a good idea to save, so we can go ahead and do that. Now we can do the same thing for the precision fit on the south end. You can see it's at 0.50 right now. If we double click it and change precision to 3 decimal places, you'll see it's actually 0.498. And that's because at max material condition, we want this piece to be no larger than 0.498 to give at least a 2 thousandths allowance. So there'll always be a 2 thousandths gap even at the extreme end of the tolerance. So we'll add our deviation, and in this case we want this to be no larger than 498, so we can have zeros for the upper tolerance and minus 5 thousandths for the lower tolerance. Okay, so now that our drawing is done, we want to either print it or output it as a PDF, and to do that, instead of going to File, Save, Save As, up here on this bar we actually have an Output PDF, and we can click that to save the file as a PDF and open it from there. So now we can open it as a PDF, and we have a nice PDF that we can print out or upload anywhere we wish. Well, I hope that helped. Have a good day.